Good morning everyone. Today we are here to discuss the data models in the DBMS. First of all, what is the concept behind the data model? Data model actually is a mapping between the real world and the binary digits stored in the computer. Like database model came the portion of the real world, means you are describing the real world, you are mapping the real world to the data stored in the computer, like zeros and ones which are stored in your computer, and what is the thing or the concept which is in your mind. So data model helps to map these two. Actually it is a link between the user view of the world and the bits stored in the computer. Like you say, what I am thinking is in my mind and what is stored in the computer is ones and zeros. So how this is described to the real world, how this is described to the users, how it will be understandable by the students, how it is used by the world. So it is used by describing the data into the model. Many models have been proposed for describing the things to the real world. Like here is a student, you have to set student ID with a string, then name with a string, login string, age is also a string, and GPA, it should be a real number. This all stored in computer and the one is in the mind of the people, and data models help to map these zeros and one and the mind of the people. How it happened, we will explain in detail. So what is the data model? A notation for describing data or information. How to describe the data and information is the purpose of the data model. It consists of three parts. The one is structure of the data, how data is stored in the table, and operations of the data, what are the operations we are performing on the data, and the third is constraint of the data, means what we can have to be what we cannot apply on our data is the constraints or the limitations of the data. Like structure of the data we describe in the arrays, in the form of arrays, structures or objects as object oriented language. Operations like queries, we have to update the data, delete the data, store the data, manipulate the data, edit the data. These are the some operations which we have to be performed on our data. And the constraints of the data, like what data we cannot enter in the database, or data which we cannot enter, which which is the restriction of the data. If that data is entered, our database can be corrupted. So this is the what data model doing. It tell us about the structure of the data, what operation we can perform on the data, and what are the limitations, constraint that have to be applied on the data to describe the data, to achieve the data, to retrieve the data very efficiently. This is some brief history of the data models. In 1950 we had the file system in which data is punched on the card and used. But in the 1960s here IBM's developed the IMS, that is the data international management information management system, in which data is organized in the form of files and it is managed by the some intelligent system. Then in 1970s here comes the CODASYL is a DBMS, CODASYL DBMS. It is also CODASYL and IDMS is a DBMS which is used for networking purposes. Network data in which one data is initiated as a root and then there is a child and this hierarchy. This CODASYL and IDMS is used for the network purposes and hierarchical purposes, in which there is some order, there is a one at a upper staff, then the lower, then there comes the more lower. So this is used for the network purposes, and the positive point of this is it is a multi-user networks. Then in the 1980s there comes the relational models, which we also used as a days, like the Oracle, DB2, Sybase, Paradox, DBase, etc. And nowadays after 1990s we work upon object oriented models, object relational models. So today we are discussing the relational model. So what is the relational model? First of all, what is the meaning of the relation? Relational means table. When the data is stored in the form of table, we said it is a relation, and the collection of tables, collection of relations are the relational model. In this relational model, we have the concept of sets. Sets is when the same type of items are stored in a one attribute, we said it is a set. And for maintaining the set, we have to apply the data. It should not be in any order. We can simply add on the data in which order they appears or comes. And one thing we have to maintain about the data model is that there is no duplicacy of data, because if we are duplicating the data, it will not save our memory space. It will have to be finish our memory space if there is a duplicacy of data. And if there is a duplicacy and one has to be changed the data, we have to alter the data at all the place. So duplicacy should not be there. And first is sets and the other is mapping. First of all, we should discuss the domain. What is the domain? We said domain. What is the domain? Domain consists of restricted set of values. Means if there is a one we have to enter the data, we should set its domain, that what type of data should be there, and in which range. And in which range means, if suppose we have to enter the whole number, then domain is to be the numeric part, and the range is start from 0 to 9. Means the whole numbers range is 0 to 9, and the domain is, it consists of numeric data only. And to match the domain with the range, we have the concept of mapping. We have to map the data. We can map the data 1 to 1. Like one student can have one registration number only. So this type of mapping is called 1 to 1. One student can have exactly the one registration number. This is called one to many mapping. And other is one to one mapping. Other is one to many. When one thing can have many values, like one student can study many subjects, then it is said to be one to many mapping. When one teacher, many students can be studied with one teacher, so this type of mapping is said to be many to one. When many students can be applied in many subjects or many tests, we said it is a many to many mapping. When there is a one domain and have exactly the one value, we said it is a one to one mapping. When in one domain and many values can be there, it is said to be one to many mapping. When many domains can have exactly the one value, we said it is a many to one mapping. And when many domains can have the many values, we said many to many mapping. Now to describe the data model, we have to describe their definition first. The data model is a collection of concepts for describing data. And the database schema. Database schema is a description of a particular collection of data using a given data model. Means we have to describe the data using the data model. It is said to be database schema. Then the relational model of the data. This is the most widely used model today, and the main concept behind the relation is that a relation consists of tables and a table consists of rows and columns. Relation is said to be to the table, and a table consists of rows and column. So what is a relational model? It describes the rows and columns. Every relation has a schema. Schema is what? Description of the data, means what are the attributes in the relation, what are their data types of the relationship, like as it is integer type, numeric type, character type, etc. So schema describe the particular description of the table. Now here you can see this is the table. We have a table having the 4 attributes: student ID, name, phone and DOB. DOB is date of birth. This green color I have written schema. This is the schema of the table, like student ID, name, phone number and date of birth. These 4 consist of the schema of the table, and this particular 4 are the attributes. Here it is designed, it is shown by red color. This red color shows the attributes in the table or relation. This student ID is attribute, this name is attribute, phone is attribute and date of birth is a attribute. And these 4 records, these records are said to be tuples. One record is a one tuple, one other record is another tuple. This is the third record, third tuple and the fourth record. So in this relation we have 4 attributes: student ID, name, phone and date of birth. And this is the schema of the relation, that is student ID, name, phone number and date of birth. These 4 consist of schema, means what is the description of the table. This is the description of the table, this is the schema of the table, and the record is known as tuple. So this is the one of the hierarchy, or you can say the nomenclature of the relational model. So relational model is based upon tables, because relation, what is the meaning of a relation? Meaning of a relation is table, and relational model is based upon the table. When data is stored in the form of table, we said it is a relational model. The structure portion resemble an array of a struct in C, means for describing the data structure of the relation, we have to describe the table in the form of arrays, like column header become the field name. Each row means what is the value struct in the array, what is the content stored in the table. Now these are some of the characteristics of the relation model. Relational model is very general, so it's not difficult to understand the table or a relation, because it is very general. Whatever the real world nomenclature, we can use the same, like student ID, we said student ID, like name. So there is no any technical term which cannot be understand. We taken the values, we taken the table as it is in the real world. Real world means, like I have to gather the student information, I took the name of the table student and the attributes student ID, name, address and date of birth. So it is very general, simple. It is very simple to add the values in the table. It is very simple to read the values from the table. So relational model is very simple. Flexible means easy to change. Flexible means when we can easily update the table, we said it is flexible. We can easily insert more data, we can easily delete the data, we can easily update the data. So it is very flexible and easy to query, declarative without programming. The one of the most big application of relational model is that for doing any query, for fetching any data, it should not require any programming. We can easily fetch the data from the database by simply putting any query, like select command, insert command you have done. By simply putting that commands, we can easily fetch the data from our database. We should not need any complex programming. But because as well by this, it also have a very good features like good design essential, integrity essentials. Integrity means validity, or the validity of the data or correctness of data is known as the integrity. Poor semantic, like a semantic of the database something poor, like those select command, update command, we have to write many to fetch the data, so koi mat nahi. Relationship based upon the value matching, like for upgrading any data or fetching any data, we have to match the values, like the name should be there, we should remember the name, we should remember the city, etc., whatever the query you want to put on. So these are some informal guidelines for putting any queries, like semantic of the attribute should be easy to explain relation, don't mix the concept, like these attributes are very easy to explain the relation, like if we explain the attributes we can easily explain the relation. This reduce the redundant values in the tuple. So this is the one of the good feature of the DBMS, that it helps to reducing the redundant. Redundant means duplicate values from the tuples or from the table. Choosing attribute domains that are atomic. We should have to pick the domain, like domain means restricted set of values. If there is a student data information and I have to put the names, what I am doing, I can store only the name of students which are enrolled in the semester, or you can say any course. So this is the domain of the student, that we can add only the name of those students which are enrolled in our course. And the domain should be atomic, that should should be the duplicacy of domain, and reducing the null values in the tuple. Null value means those values who do not have who not contributing anything, जिन्हां दी values present ही नहीं हैगी है, we said these are the null values, or disallowing any superior tuples. So no duplicate tuples in a relation, it should be a no ordering of tuples in a relation. A relation is a set. Attributes of a relation have an implied ordering, and every tuple must have attribute value drawn from all of the domain of a relation or special value null. All the domain values and hence the attribute values are atomic. So these are some comparative terms which we use formally and oracle. In the formal, we said it is a relational schema. What is the relation? Relation is a table. Relational schema means description of a table, and we said relation means table. We ask tuple is set to the row. We said attribute is set to the column. We said domain is set to the value set. For example, notation course. Now the course is the name of a relation. Course number, subject, equipment, these are the attributes. And the second relation is student number, name and honors. This is the second table. And the third is enroll. Enroll is for student number, course number and lab marks. Now before doing the discussion on the content of the table, we should know about the keys. Key means, first of all I would like to tell you the meaning of key. Key means uniquely identified. That value which is uniquely identified, the table or a table values, we said these are the keys. First of all, there is a concept of super key. A super key is a set of attributes whose values together uniquely identify a tuple in a relation. When two or more than two attributes uniquely identify the tuple in a relation, we said it is a super key. Like address and department. When we combine the address column and the department column that uniquely identify the relation, we said it is a super key. Primary key is a super key for which no proper subset is a super key. A key is minimal, can be more than one for a relation. And the other is primary key, a candidate key chosen to be a main key for the relation, and it is only a one for every relation. Like if we taking an example of elections, there are so many candidates to be a MLA, to be a prime minister, and to be a minister. So many candidates who are eligible for the any key post. These are the candidate, and one is selected for that post. This is just example. There are so many people, or a 5 or 6 people who can be a MLA, who stand in the elections. They are the candidate key, and the one who is particularly chosen to be a MLA, that is the primary key. From the candidates, from the suitable candidate, we pick the one to be a primary key. In the same way, in our relation, we have 4 or 5 candidate keys which can be a super key, but we pick the one to be the to uniquely identify the relation. We said it is a primary key. Keys can be composite, means if one relation do not uniquely identify the values, we can combine two attributes to make the key, and that type of keys are known as composite key. Now there is a concept of foreign key, a set of attributes in a relation that exactly matches a primary key in another relation. Means that if there is a suppose we have two relation, and one is a primary key in one relation and other is not a primary key in another relation but present in another relation, we said it is a foreign key. Like here you can see there is a student table, student number, name, tutor and a year in the student table, and there is a staff, lecturer, room number and appraiser. There is a two relation, and here primary key is student number and here primary key is lecturer. So what is there, if there is a student number in the staff relation, then that student number become the foreign key of the staff. Means one attribute who is the part of other relation and the primary key of some another relation is known as foreign key. So there are some restriction of the foreign key. The name of the attribute do not have to be same but must be of same domain. It's not necessary that they contain the same name, but the domain should be same. A foreign key in relation A matching a primary key in a relation B, representing many to one relation between A and B. Here you can see student number, name, honors, tutor and year, and in the staff there is lecturer, room number and the appraiser. The primary key of student table is student number, because this student number will not be assigned to other student number. It is uniquely identified. This is the student number. Here in this lecturer is the student number, primary key, which is uniquely identified in this staff column. Here name can also be a student key, primary key, and these two are the candidate key, and we chosen the student number as to uniquely identify the key. So this become the primary key and the name become the candidate key. Now the referential integrity. Referential integrity is same as the foreign key concept. What it means, when the primary key of the one table is in the simple attribute of another table, we said it is a referential integrity. We have the three operations that can be applied on this. Cascade means delete all matching foreign key tuples. This cascade will delete all the matching foreign keys tuple. For example, student restrict means can't delete primary key staff with list of foreign key tuple student matches. This restrict will help to not to delete the primary key. Nullify means foreign key student tutor set to null if the foreign key ID is allowed to take on null. Now the entity integrity and nulls means what is the null? Null means the null, three categories of null values. If their values are not applicable, we said this is the null value. If the value is not known to us, we said it is not known, or we said it is a null value. If the value is not recorded, absent, we said it is the null value. Here you see in the student relation, there is a no thesis title assigned to these students. So this is the null values. These are not recorded or not applicable to this. And this in the honors column, the Smith does not have any honors, so it is not known or absent from the data. So these type of values are known as the null values. Values which are not applicable, values which are not known, and values which are not recorded yet. And the integrity means the value should be atomic, it should be known by their domain, and sometimes can be null. So this is the integrity of the entities. Now these are some definitions which have to be taken care in the relational model. First of all, Cartesian product. This Cartesian product is represented by the cross between the n sets, is the cross between n set. N set is a set of all possible combinations element of those set. Then there is a domain, set of all possible values for the attribute. For attribute A, the domain is represented by the DOM A. A domain has a format A and B database values. Means for the domain is represented by the word DOM and domain for the attribute A. What are the domain for the attribute? Domains means set of restricted values. Then comes the relational schema. Relational schema, as I told before, it is the description of the table. What is the description of the table? Like what are the attributes in the table? So it is denoted by R bracket start A1, A2, AN, where A1, A2, AN are the number of attributes in the relation, and the relation is represented by this R. Then relation is a subset of Cartesian product of its domain. Given a relation schema R, a R relation on that schema, and a set of attributes A1 to AN. So attribute a function on a domain for each instance or a mapping or a tuple. Attribute value, what are the content you have stored in the table, the result of the attribute function. Now the tuple, as I told before, it is the one record is known as tuple, a set of n attribute values pair representing the single instance of the relation. Then the degree is number of attributes present in the relation. जिन्ने column होंगे table ਦੇ ਵਿੱਚ उन्नी उदी degree होएगी. And then comes the cardinality. Cardinality is number of tuples in a relation. How many records you have stored in the table? Suppose there are 8 records, then the cardinality is 8. Suppose there is a 7 records, the cardinality is 7. Then comes the roles. Roles, several different attributes can have the same domain, and the attribute indicate different roles in the relation. Then there is a keys, as I told before, key, super key, a set of attributes whose value together uniquely identify every tuple in a relation. These are known as the key. Then there is a candidate key. Candidate key is a super key that is minimal, means one single record, and that has no proper subset that still uniquely identify every tuple in the relation. Then there is a primary key. A primary key is a candidate key chosen to be a main key of the relation. There is only one primary key for each